This is good. This is kind of like what we talked about yesterday really kind of set the stage for the work we're going to do today. So today, don't be shy. This is everybody, this is an all play, okay? Everyone roll up your sleeves, get your coffee, shut your email down. This is where we're starting to do the real work of the workshop, okay? So I want you to stay with me. I invite my panel to go ahead and turn their cameras on. So I know Sanaz is there, Yong Wei and John. Go ahead and turn them on. And Terry's here in the room. She's going to come up when she does her session. So what we're going to talk about today, and I've invited my federal family colleagues to join me here, is as Dan described, we at ASCE 7 have been partnering with federal agencies for some time now on the hazard development for the data for ASCE 7. So this is how this came to be. These are some examples of things that are working for us. They were all born organically. So there was no one process, there's not one agency, there's not one anything. So this is some examples of how things can work. And what we could do, since we're starting from the beginning, is maybe cherry pick the best that we would like to pursue and go forward with that. So the breakout sessions this afternoon with Dan and Brian and myself, let's really start thinking about how we might want to see some of those processes working. And again, I'm going to walk through 7. That is very different than all of the other documents that are out there, the manuals of practice, other ASCE standards. 7 is probably the most highly regulated, the most rigid process. So if it can work for that, as we say that here all the time in ASCE, if it could work for ASCE 7, hopefully it should work for most of the others too. So with that, we have a very long title here on the programmatic durable. You saw it. All right, we're gone. All right. So our panel that we have online, Sanaz, she's a research structural engineer from USGS. Terri McAllister is here in the room, Deputy Division Chief from NIST. John Ingargiola, Lead Physical Scientist, Building Code Policy Advisor from FEMA, and Yong Wei, Senior Research Scientist at NOAA, PMEL, and University of Washington. So we will get to them in just a minute. The agenda for this quick session, and we have 90 minutes. So this is a nice long one. We have 90 minutes. I'm going to give a little overview from the ASCE perspective. We're going to talk a little bit more using kind of that theme that I went through yesterday of kind of the cadence of how these things are developed and then adopted. Then we're going to switch over to my colleagues for the agency perspective. What really works for them internal to their systems? This is not technical. This is process. How does it work for them? Then I have a few questions for the panel, and then I'm going to open it up to you all. So we're going to have a nice long time for Q&A. So again, start writing your questions down, things that you want to ask the panel, things that you want to ask us about process, so we can have a nice discussion here. And again, reminder, when we speak in the room, we need the microphones so everyone can hear you online. And the folks online, of course, if you have questions too, are we putting them in the chat? Are we raising hands? Either raise your hand and we can unmute you or put it in the chat. So everyone is engaged. I'll play. All right, next slide. So this is what you saw yesterday, okay? This was the big kind of scary 10-year timeline that I talked about yesterday. And I had a couple of conversations after my presentation where they were like, we can't wait 10 years. Oh my gosh, we got to do it now. Yeah, totally. I get that. But this is actually just, again, as I kind of back up the bus and say, this is a very highly structured process that works for ASCE 7 in the buildings environment where it's highly regulated with a building code that's adopted nationally for the most part. That's the process. There are many opportunities for the work that we're doing today to start being put into the manuals of practice that can be uptaked by design engineers or local jurisdictions. And in fact, if a lot of times we're talking about, I don't have a pointer. For those of you online, I'm pointing to 7. A lot of times we develop the standard and then we go right to adoption. So we can cut out this middleman of IBC and maybe shorten up some of this. So there's a lot of ways we can get there. It doesn't have to be just the 10-year process is the point I'm trying to make. So the part of that whole process that we're going to talk about for the next 90 minutes is just this front end. We're going to talk about how the research is developed, specifically talking about through a big federal agency, okay? How the research is developed and then how it can be tailored, co-developed, I think was the word that we were using yesterday, how it can be co-developed so that it's ready to be used in the standard. What is the format? What does the language look like? All of that kind of nuts and bolts. Terri and I were just talking about that this morning. We often look at these projects technically to try to solve the technical problem and say, okay, here's the solution for this coefficient, that value that Shelby was talking about yesterday. What are the units? What's the thing I have a unit on? That's what we focus on. What we don't focus on is what Mitch was just talking about. How do we communicate that? How do we get it into the document so it's usable? How do we create the website, the web server, something like that, so we can download that information? Okay, that's what we're talking about. So you saw this yesterday. Again, these are the hazards that come into particularly ASCE 7. These are the agencies that we partner with. Now they're color coded. You can see there's red and blue. Hopefully, hopefully you notice that. So for the federal agencies are all red, and then ASCE is blue. So ASCE actually has some skin in the game here too. We try to develop the hazard where we don't have an agency maybe to work with, we don't have a regular funding cycle, or we're starting something completely brand new. Yong Wei is going to talk more about the tsunami provisions and how those came to be, but that was heavily invested by ASCE, partnered with NOAA. The other thing we've done recently are the snow maps. The Army Corps used to do this with CREL, and that has since faded away, that relationship, that effort. They do a little bit more with ICE, but that really is just volunteers volunteering their time for the standard. It's not at the agency anymore. So what we did is ASCE invested in that to develop that process. So it's both skin in the game from the society and from the partners. Okay. So what I wanted to point out was, and Dan talked about this, and Sanaz will go into it in much more detail, is that NIHR provisions provides that appropriation, I always get it mixed up, provides the appropriation. Every year, ASCE also comes to the Hill and says, yes, please fund this, both NIHRP and NWERP, to try to get funding for these hazard development. But right now, that's the only one that ASCE counts on. Every year, that gets fully updated. Sanaz is going to go through their timeline when they actually start the work, but that's fully funded. It's in the flywheel. We do it every 6 years, and we jump in occasionally to do that co-development. So there's a couple of more layers to it. She's going to talk about that. But the next one is none of the other ones have a consistent funding method. None of them. Not the ASCE ones, none of them. So what we do is each time the cycle comes around, or actually at the end of the previous cycle, we say, what do we need to do? And we look at the data and we say, we're gonna spin up this project. We're gonna talk to them over here about this, and work together to see what actually needs to be updated. That's how that works. Okay, this is a typical timeline. There's no years on it. Well, the years is for ASCE 7, but I'm sorry, it's the 28 edition. But in there, I wanted you to notice, I guess there's no line numbers. Third down, you see some negative numbers here on the left, the pre-development, and then the development cycle. As I was saying yesterday for ASCE 7, this isn't true for all of them, but we're on a 6-year cycle. ANSI says we have to be on a 5-year cycle. It could be shorter than that if the committee is really excited and gets it all done. Doesn't usually happen, but it can. So it's about 5 to 6 year cycle that you're in development. And when the committee's working, they don't have a lot of time to do that extra research. So that research wants to be done beforehand. That research wants to do the pre-development work all the way here on the left-hand side. That can be, 2 years, 1 year, 4 years before we actually hit the ground running with the standard development. So you can see the research and development kind of timeline straddles when we get started. Oftentimes they're finishing up their work. We're getting started. That's on purpose. And then there's a handoff. Hopefully a nice, easy one. Sometimes a little clunky, but a nice planned handoff. Here's the research. We know it's coming. We know exactly what it is. And then we bring it into the document. That is the best way. And then the committee does its development work. We publish, and then we go into adoptions. Okay, that's kind of the generic cycle, if you want to think about it that way. Okay, so that was my little preamble on kind of a deeper dive on how these things could work. We're going to go into very specific examples. Here's our team, we're gonna talk about the seismic hazard first. That's that really well-defined one that's comes through NEHRP. Then Terry's gonna talk about the NIST effort. John's gonna do flood, and we're gonna end on Yong with the tsunami. And then I'm gonna come back up and we're gonna have a few Q&A to the panel. So now's the time, start thinking of your questions. After I quiz them, then you guys get your chance, okay? I'm gonna sit down, go ahead. So it's Sanaz, it's you.
Hey, can you guys hear me?
Yes.
Okay, great. So good morning, everyone. I'm Sanaz Rezaeian. I'm a research structural engineer, as Jennifer mentioned, at the U.S. Geological Survey. We have our website, usgs.gov, that describes who we are, what our vision is, and what our mission is. And in short, we are basically the science arm of the Department of Interior. This is an agency that has been created and funded by Congress since 1879. And as it was mentioned, we have the advantage of our work being funded regularly. And I will explain a little more that we do actually justify this over the years, the continuation of this funding by how important our products are in the building code. So it's kind of like the reasoning for existing is helping us to be funded and so on. But that's only because we have gone through this process, and it has been many cycles that our products have been used by the public and the building codes. As you can see at the bottom of this screenshot that I'm showing to you guys, the USGS, one of our tasks is to partner with external engineers and users to provide objective and impartial science to resource managers, emergency response, and the public. And that includes ASCE 7 standards. Next slide, please. So within the USGS, we have several different programs. One of the programs is the Earthquake Hazards Program, or EHP. And under that program, we have several important projects. One of the projects, our flagship projects, is the National Seismic Hazard Model Project, or NSHM. And I'm showing a snapshot of the website for that NSHM project, where you can get more information about what our mission is, how we get funded, and what our cycles are. And basically, this is the project under which we develop the data that go into ASCE 7 standards and other building codes. And that's these colorful maps that you see at the bottom of the page that give people the intensity of ground shaking or probability of exceeding certain intensities given a certain level of risk. So there is a lot of work that goes behind the scenes to produce these maps, many input models and data sets and our interpretations of them to develop this data. And that's a few years of process in updating these NSHM every cycle by itself. Now, within the NSHM project, we have a task that's called the Design Ground Motion task. It's been very helpful for us to have 1 to 3 engineers dedicated to this task. And including myself, our job has been to just interact with our engineering users and try to transform this hazard data from the NSHM into data that is usable for practicing engineers and goes into ASCE 7 standards and other building codes. Again, we have a website for the Design Ground Motions. That's where we have a lot of information and web services. It's not as pretty and graphical user interfaces, or they don't exist, but that's where all the work happens to transfer this data that we have into something usable for our users. I also put the task leaders here. Over the years, Nico, Luco, and myself have been leading this design ground motion task. And as you can see, the project chief for the NSHM project recently has been assigned to be Nico Luco as well. So I'm mentioning this because I feel like the continuity between our leadership between the two projects and our interactions with the users has been really helpful in getting this process into the building codes. Next slide. Yeah, this is the main slide I wanted to jump into anyway. I think we got everybody's attention in the room now. And this is a slide that shows the interplay between the USGS and ASCE 7 standards over the years. So you can see in the left column that USGS and SHMs have been used since 1996 in the building codes. Before they go to ASCE 7 standards, as Jennifer mentioned earlier, they get adopted into the NIHR provisions. Now, in NIHR provisions, that's where we do a lot of the technical work. So what we produce at the USGS is good relative data, but it's not ready in terms of the parameters that engineers need. So we actually work with the BSSC PUC, which stands for the Building Seismic Safety Council's Provisions Update Committee, to update the site-specific procedures of the NIHR provisions at every cycle. And that's how we combine our hazard data with the site-specific procedures that NIHR needs to update the design parameters for seismic chapter of ASCE 7 standards. Now, within this process, as I mentioned, one of the advantages of our group working with ASCE 7 is that we actually have liaisons, USGS liaisons, serving on NIHR provisions technical committees. Once NIHR adopts our maps in combination with their own procedures, we move this process into ASCE 7 standards, and you can see that again since 1996, these maps have been adopted in ASCE 7. But that process by itself also takes a couple of years. And we do have USGS liaisons sitting on the various technical task committees to achieve this transition from NIHR provisions into ASCE 7. After that, we're still not finished. We have another year or so to get the maps proposed and adopted into international building codes. And that's when things actually become guidelines and regulatory rules that engineers have to follow. So you can see that since 1996, USGS has been updating these maps. These are cycles of 4 to 6 years, depending on the cycle, with the latest one that was just published in 2023. Currently, we are working with NIHR provisions to get these latest maps into 2026 NIHR. At the same time, we have started going to ASCE 728 committees because we want to make sure that these engineers who are on ASCE 7 committees also understand what went into the science of updating the USGS and SHMs. And as you can see, we kind of envision all of these to go into 2030 IBC codes, assuming that they get passed through NIHR provisions and ASCE 7 standards. So there is a long lead time, even though we have done this so many times, and this is a process that is repeatable. Pretty much everybody know what their roles are and how we're getting data to our users. It still takes about 7 years to do to get the new data into practice. Could you go to the next slide, please? So now what I showed to you guys in the previous slide was when we go from the published data, that was our 2023 NSHM, the latest one, into ASCE 7 and IBC. The thing is, at the USGS and inside the NSHM process and the project, we have to think ahead of time for the next update cycle. So what you see here at the end of the table is our 2023 deadline and the publication of NSHM documentation being on the bottom row. So we actually planned this timeline back in 2019. So we gave it about 4 years to ask for any external data and models to come to us in 2020. We started by a kickoff workshop to announce to the community who give us the data and input, but also to the user community, including building codes that were starting this process. Give us your feedback, what you didn't see, for example, in the last cycle, and you would like us to do in this cycle. Let us know all those information. We develop a draft version of the model, have various public workshops, and then 2023, as you see, we work on the final model and get peer reviews from our users. One of these users is the BSSC PUC engineers. So we want to start getting these feedback early on so that they can be incorporated into the final model that will go into 7 years later into IBC. Next slide. And this is the final slide that I have. Even after the data has been approved and transformed into design parameters that engineers use in ASCE 7 standard and other building codes, we still have to physically get this data to our users. And that's what this slide is for. This is the part of process that people usually don't think about, but it does take us usually 6 months to a year just to get the data physically to our users. So I have 3 bullet points here because I thought these are the most important things to think about when you are putting a new system together. Basically, we have found that having a reference URL address, a digital object identifier that doesn't change in ASCE 7 documents is very useful, so you don't have to update that every cycle. What we do with this DOI address that you see on the top is that we use this as a design ground motions portal. So every cycle in this portal, we add links and drop-down menus to the ASCE 7, and you can see other building code documents as well to have more information under each one of these drop-down menus. One of those information is the actual geodatabase that we save, even though we have our dynamic process of updating ground motions, and we have the ability to calculate seismic data on the go. We want to lock this data at certain periods of time, basically to make sure that, one, there is a backup just in case something happens to government, there is a shutdown or something. Also to make sure that the data that we have discussed with all these committees, for example, they have looked at certain numbers at test sites. We want to make sure that data is logged in and is not changing, even though USGS is continuously updating their models. So this geodatabase, we have been using Sciencebase in the past few cycles. This is relatively new. We didn't do this in 1996, but it's something that we have switched to. I think most government agencies are required to use Sciencebase for data releases. So it's a very formal process. It's very useful because it's a standardized way of organizing our metadata and publishing our data releases. Now, the third piece of information, the third bullet point here, is actually when we interact with ASCE 7 personnel and staff quite a bit, because we develop web services. Now, we call these web services and not websites or web tools because they don't have a nice graphical user interface. That falls on ASCE 7 hazard tool. So web services is where we actually put things together to link our geodatabase and convert that data to the design parameters that ASCE 7 hazard tool wants to output for the users. So when you go to our USGS Seismic Design Web Services site, what you see are links. And underneath each one, you get instructions on how to build a URL with your input parameters and how to get your output parameters and what they are. Now, what ASCE 7 Hazard Tool has done is they use our web services that we prepare for them, but they spit it out with all other data that engineers need in a nice graphical user interface box. So this whole process by itself, I think that everybody should think about ahead of time. It does take some months, up to a year, to make sure that everything goes smoothly and that our web services links are working correctly, they're not broken, all of those extra work that we usually don't think about when we're working on science and technical part of things. I think that that's all I had. Could you go to the next slide just to make sure? Yes, that's all I had to tell you guys. Yeah, sorry for the longer time, but I'm here if anybody has any questions.
Thank you, Sanaz. I appreciate that. And thanks for hanging in there. We're going to turn it over to Terri next here. She's in the room. She's the only one here, but she's going to go through NIST. Thank you.
Okay, thank you, Jennifer. Okay, so good morning. I've been asked to focus on the support that NIST has provided for wind and tornado hazards. And actually, one of the technical leads of this work is sitting in the room, Long Fan. Mark Levitan is online, I believe. And Frank Lombardo also had a role in this earlier on. I don't see him here today. He is online, okay. I just want to start out with the NIST mission. And our mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology in ways that enhance economic security and improve the quality of life. This is true across NIST, and the engineering laboratory interprets this in ways that often lead to work that supports the standards that we're talking about today, as well as many other types of standards. So, you know, the basic idea is if you can't measure it, you can't tell if you're meeting a goal, you can't tell if you're improving or advancing. So this idea of measurement is really key. And just for an overview, you know, NIST has over 550 technical staff involved in over 300 standards committees. So it's very much a core value at NIST. I did want to mention in particular in the engineering laboratory that a big part of our science, understanding what needs to be addressed in terms of standards, is our disaster and failure studies program. So the 2011 Joplin tornado led to an investigation to look at what happened there in terms of damage to buildings. And that informed the tornado work that I'm going to be talking about. We are currently still documenting the recovery of Puerto Rico following Hurricane Maria and the wind and flood events there. And I am positive that that's going to have some impacts on codes and standards as well. This is something that NIST has been doing since 1969. So that's just kind of a general background as to why NIST is in this space. Let's see if I hit the right button here. Thank you. So the NIST process, Jennifer said, you know, this is somewhat ad hoc because we do it as opportunity comes up. We don't have a well-financed, oiled machine like we just heard about relative to, you know, the earthquake programs. So NIST, one of our goals is to identify research and development that has a strong impact to society, to the well-being of our country and you know, just its citizens and its economy. And so one of those was the Joplin tornado, and more generally, our structures group focuses on wind hazard characterization and structural design, structural response to wind hazards. We have a long history of collaborating with ASCE through the Wind Load Subcommittee and the Load Combination Subcommittee, at least since 2000, and I think maybe the Wind Committee prior to that. We do use contracts to support our work because we're small. So we often need to have contracts to help us do the work that we've identified. So for the wind studies, we've been using Applied Research Associates, and I know they're online today too. And we also really believe strongly in NIST workshops for stakeholder engagement and feedback, much like we're doing here. It is so important to hear from everybody and understand the bigger picture before we narrow down and focus on what we think the key issues are to focus on. And this graph picture on the right is just current work that we're doing with the University of Florida relative to Puerto Rico, looking at the effect of mountainous regions on the winds and wind mapping that goes on in Puerto Rico. I know similar work has been done in Hawaii, for instance. Okay, so I'm going to go through the process to develop wind hazard maps for ASCE 716. We were talking about this in our session yesterday. NIST has done a lot of internal work for non-hurricane winds, looking at the historical wind data, separating peak wind records by storm type. So what happened, this is when Frank Lombardo was at NIST before he moved to the University of Illinois. He and others in the structures group realized that it was time to update the wind data. It had not been done so for a long time. There was many more records available to improve the quality of the database and to form a basis for the models that we use for wind hazards. So what's listed here is the steps that were gone through to assimilate all this new data, clean it up, fit it to the hazard models, and start using it to develop updates to the wind map as you're, I'm showing here on the right. And I just want to thank Mark Levitan for developing this slide. I'm talking through it, but Mark very kindly put this all together. You will notice, for ASCE 7, the peak criteria, the key criteria for wind speeds are 3-second gusts. We went to that because that's what the news, your meteorologist on your TV was reporting. We were using different length, measurements for wind previously, and the public didn't understand. So this was one of the changes we made so that when we spoke about wind speeds, the public understood what we were talking about because it was what they were hearing on their news channels. We continue to measure it at 10 meters over flat open terrain. And we have something called risk categories in ASCE 7 that allows us to account for the importance of the structure. But that's a topic for another time. So I have here the report issued in 2015 of the work done for the internal research on the wind data here. And of course, to bring this into ASCE 716, there was collaboration with the Wind Load Subcommittee, the Load Combination Subcommittee. The Wind Load Subcommittee wants to look at the science and how this data works for design. The Load Combination Subcommittee wants to look at how the wind speeds and the resulting loads meet the reliability criteria. Target reliability for all hazards is what makes the document consistent in terms of performance of our buildings. And then we had contract support from ARA for the hurricane wind speed modeling because that was not part of the data that was available at a lot of the wind recording sites. And then there was this approach that was developed to combine hurricane and non-hurricane wind speeds into a final basic wind speed map. So we had different hazard curves, one for non-hurricane winds, one for hurricane winds, and then they developed one that combine both, kind of an upper envelope approach. Now, for the tornado hazard wind maps, this is for the last cycle, ASCE 722. You can see there's similar steps here. NIST worked with ARA to develop the climatology for tornadoes, as well as I think some other ASCE committees, and really trying to understand the basis for measurement here. You can see there were 3 workshops because this is such a new area. This is the first time tornadoes have ever been developed into some kind of a design criteria that can be used. Before, there were just these general maps and good luck type of advice, or there's nothing we can do about it kind of advice. So this is really, really, I think, a huge milestone for the engineering profession to stop treating tornadoes like the impossible problem that we can't figure out. Just to give you some context, this is for EF 0, 1, and 2, which is, it's 95 to 98%. Long is it? 97, I was close, okay. 97% of tornadoes. So we have not addressed, the last 3%, which we know are very damaging, but it's like a lot of our hurricane winds. If you can keep that debris field down, that lowers the damage that's occurring everywhere else. So again, we had collaboration. We did the technical approach confirmation with ASCE 7 experts on the wind load subcommittee, and then the reliability analysis. One other thing I want to mention here, it's always so important, is we are so fortunate at NIST to have an applied economics office. We have economists that work with us, and they do studies about the benefits and the cost of incorporating this into design practice. And it's helpful for ASCE 7. It's almost essential when you go to the IBC because you have people that really want to know, is this really worth doing? And they think in terms of dollars. And so you have to help them see what the immediate costs are and what the long-term costs are and what the benefits might be. Okay, so where we are right now, we are very much engaged in supporting the development of future conditions for wind maps. There's research starting for the tornado hazards, so it's not expected in ASCE 728 that we're going to be able to address it by then. But we recognize that it's a long lead item, so work is starting in that area. So some of the things we're doing now, we have climate funding that we received last year from Congress. Congress is very interested in how we're going to move climate science to codes and standards. So we are very pleased to get that funding so we could help support this work. One of the things we did last year was we had 3 workshops. We collaborated with NOAA and ASCE, and we wanted to identify leading practices that communities are using for sea level rise, precipitation and flooding, and wildfire. These are the 3 areas that we hear communities talking about most often, and they are making decisions about this, have been for the last 5 to 10 years. We do have a report that will be coming out sometime in the next month documenting the workshops and what was found. And in parallel, we are working on a roadmap. This is a report where we are looking at the current practice, trying to identify critical gaps that will keep us from moving forward in this area of moving climate science to codes and standards. And part of that is funding others to work with us. We have grants and cooperative agreements. Some of them are in the process of being funded, so I cannot discuss what they are, but they are aligned with the ASCE 7 activities that are going on right now. Here's 2 that have been funded. quantifying the risk and impact of wind and hailstorms in a warming climate, and quantifying non-stationary tornado risk in a warming climate. Of course, we are participants in the ASCE NOAA task force, and I will say that's been immensely valuable to get a better understanding of what our sister agencies are doing, what ASCE is looking for, and I'm hoping it's going to lead to improved collaboration mechanisms between federal agencies. And so I think that's all I have there. There we go. And on to John.
Thank you. Thank you, Terry. As we get John tuned up here, I wanted to just point out a couple of things that they've been saying. So process, we're talking about internal to the agency, but also beginning with the end in mind. How are we going to write this down in a way that we can use it? How are we going to deliver it? How are we going to justify it? The economic studies that Terry is talking about have been absolutely critical for getting tornadoes like into the IBC, into the regulation. So think about that as we go forward. The technical is easy. The people are hard. So we can work on how we can communicate, how we explain, how we can partner. These are as important, if not more so, than the technical. I think that's the message you're hearing. Okay, John, are you ready?
I'm ready.
Thank you.
Thanks.
Please go ahead.
And mine is probably going to be the shortest. That's not, not on purpose. It's just a recognition of reality that what I'm talking about, we don't have the organized programs that we just heard about through NEHRP and through the National Windstorm Impact Reduction Program. There's not a similar program for flood. So you won't see a lot of the mechanics and the deep organization and planning. But we are active in this space in terms of the flood hazard. So again, I'm lead physical scientist, building codes policy advisor. I also have the privilege of being the SME lead for the National Institute for Advanced Building Codes. There are 20 federal agencies now as part of the national initiative. I just posted a link that points you to our building codes task force and the report that was just published, accounting for all of the work that the agencies have done in the 2023 in advancing codes. So take a look at that when you have a chance. I've been supporting the ASCE flood standards for quite some time, both in the ASCE 24 committees and now currently in the ASCE 728 committees with future conditions. It's not myself alone. There's 4 other staff members that are currently on committees with 728 and the flood committee and 2424 in that standard committee. Describe FEMA's mission very, very plain and very straightforward about helping people before, during, and after disasters. But that mission is coming into a greater focus in terms of resilience, and many of us, embrace resilience or describe resilience. FEMA has made it an organizational element now of the agency. The Resilience Organization, the Office of Resilience Strategy, and Administrator Criswell has declared 2024 to be FEMA's Year of Resilience, to reinforce the importance and centrality of resilience to the success of FEMA's mission. And that is clearly laid out in what's called the annual planning guidance, and it underscores our priorities: create a unified resilience organization and culture, increase all hazards resilience in our nation's most at-risk and underserved disadvantaged communities, and establish FEMA's leadership role in building national, community, and individual resilience. And on that last one, I just want to point out under that priority, we get to see a connection to what we're doing here. And it is 3.1, deepening our coordination across FEMA and with other federal agencies to achieve resilience outcomes. And several examples there in 2024, resilience will leverage interagency partners to identify shared requirements across key federal agencies to access federal resilience funds more efficiently. Also to our plans to publish the updated federal flood risk management standard regulations and complete the 44 CFR Part 9 final rule update. Advanced building codes across the federal government and the nation through program incentives, technical and policy support, shared partnerships, and awareness campaigns to increase code adoption and enforcement, and then drive further integration with FEMA regions through improved coordination across all programs and continued investments in tools and resources. So you see that this is coming into a much stronger focus than it has in the past in terms of advancing building codes and standards. And when we think about and consider, where does the data come from? What are the flood standards, and where does the data come from? This goes back to the original intent of as FEMA's mapping programs, the National Flood Insurance Program, it produces regulatory flood maps for the nation and non-regulatory products. But going back to the beginning, the desire is to have those maps serve as a basis or a platform where data and information can be utilized in the consensus standards for design and construction. And so that's been the basic goal which we have achieved, that have that safe harbor of the NFIP represented in ASCE. Obviously, we're recognizing that the way we're mapping now is has limitations and has challenges, and increasing frequency and severity of disasters mean we have to consider how to map the nation in a better way, reflective of multiple flood hazard characteristics, and look at future conditions. The data officially is linked to ASCE 7 through FEMA's Flood Map Service Center, the official online platform for all flood hazard mapping products created under the NFIP. What the exciting part is happening now is that the risk map program is moving towards the future of flood risk data, which hopefully we'll get into a little bit more, but that is going to move beyond just the binary depiction of flood hazards and a more comprehensive representation of flood hazards with the characteristics represented across different probabilities, annual exceedance probabilities, with the characteristics of velocity and waves and depth and flow, and an indication of impacts of future climate. So a lot of that is kind of laid out in what's called this risk mapping assessment and planning multi-year plan, which I provided a link to as well. Now, in terms of funding, for these mapping efforts, there's basically two sources of funding annually, and the first source is discretionary funds appropriated within the federal assistance appropriation. And the second one is actually a flat discretionary fee that is levied on NFIP insurance policies. So that's where the funding comes from on an annual basis. And FEMA is actively evolving the risk map program to encompass future conditions and a more comprehensive depiction of flood hazard and flood risk. I'm here this week at the Association of State Floodplain Managers annual conference, And one of the big hits is the new FFRD Pilot Data Explorer, where we're walking people through, what is changing with the depiction of flood hazard maps, and lots of excitement, lots of interest in what is soon to be delivered in a multi-year initiative. But many of the things that we see have evolved in the ASCE flood standards, being different mean recurrence intervals and more inclusion of sea level rise, and also the expanded horizontal floodplain. These are being complemented in what we're seeing in the future flood risk data. So just a short kind of overview of our process here. And what's interesting is that through the work of the ASCE flood standards, what has just been accomplished last May with the 722 flood supplement, and what will be accomplished later on this year with the updated ASCE 24. It represents the biggest advancement of flood hazard provisions in more than 20 years. So we're really excited. We are engaging and partnering very closely now more than ever with ASCE, and we'll also strengthen and equipped and leveraging the partnership we have with different federal agencies through the National Initiative to Advance Building Codes. So that would my comments on this portion. Thank you.
Thanks so much, John. Really appreciate you walking through that. Just because John only had one slide doesn't mean that FEMA is not doing yeoman's work here in the flood the flood area. One thing I wanted to point out, what John mentioned, is this co-development aspect. So we work closely with FEMA, not only on ASCE 7, but also in ASCE 24, and develop data support contractors to help us with both of those documents at the same time. In fact, we're in a deep dive here trying to prepare for the code hearings that are coming up next year, trying to get that supplement that John was referring to, get that adopted into the ICOES. That's going to be a huge heavy lift, and I'm looking at you, John. We're going to need all hands on deck. So get those floodplain managers rallied when you're there and bring us some help. So thank you very much.
Sure.
And so we have one more presentation from Yong Wei talking about tsunami and how we develop that. But I just wanted to mention to my colleagues here, put a link in the chat for the hazard tool. So everyone's actually mentioned that, because that's kind of the end platform, if you will, that ASCE developed several years ago to collect up all this data, to serve it up to users as well as the public. It's totally free to access that. That was on purpose because we wanted the building officials and all the regulators to be able to have access to this data without having to, work real hard. No, you don't have to pay for it. You don't have to have special permission. You don't have to be a member. It's just there for everybody to use. And since we put that out there, now it's collecting, it's attracting more attention, attracting more data, attracting more use. It started off for ASCE 7, and now it's growing. We also have data in there for ASCE 41. So that's our seismic retrofit standard, and it pulls on some different data that Sanaz was showing you from the USGS web service. We pull that now into the hazard tool as well. So all of these products, and we've talked about this at length with John Ingargiola, is to add flood data to that hazard tool. Right now it pulls in some existing data, but we want to actually develop the data in a better format and in a better way so we can purposefully add it to that hazard tool. And so again, we put that in the chat, and I'm reminded by Megan that I did do a kind of an overview on that hazard tool and kind of walked us through it. And I forgot that she recorded it, and it's available on the portal that Bilal talked about. John, did you want to make one more comment before we go to?
One
Yeah.
more final comment. I would be remiss if I didn't mention the other ways that FEMA works to get improvements, specifically with flood in our nation's codes and standards. And that is through our post-disaster research, our building performance studies, where we evaluate the effectiveness of current codes and standards, building design techniques, and through that mechanism, we've seen many advancements related to flood that are in today's codes. Freeboard is a big example. The introduction of coastal A zones is another. We also partner with different agencies on research. By partnering for the last 20 years, it seems like today there's a new consensus specification from ASTM exactly what it constitutes flood-resistant materials. And more importantly, how to test and certify them. So we contribute in that ways, and these become also integrated into the ASCE codes and standards, and through DHS partners also with science and technology advancements of standards like ANSI 2510 for testing and certification of flood abatement equipment for dry flood proofing. So just want to contribute those other aspects from FEMA's.
All right, thank you, John. So everyone online and in the room, start thinking of your questions for the panel. We have one more questions. Thanks so much. Go ahead, Yong, you're up.
All right, thanks, Jennifer. Good morning. My name is Yong Wei. I'm a research scientist at the NOAA's Pacific Marine Environmental Laboratory based in Seattle, Washington. And I'm also affiliated with the NOAA Cooperative Institute at the University of Washington. My expertise is in coastal inundation and tsunami modeling. We're delighted to join today's panel discussion. I've been involved with the development of ASCE 7 tsunami design provisions. Today, I'm going to give the talk from a different angle. I'd like to share some of my experience, the challenges that we had faced during the code development, and also some opportunities created by this process. Next slide, please. So short on NOAA's missions, they're basically in three aspects: science, service, and stewardship, to understand and predict changes in climate, weather, and the coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and the resources. I joined the ASCE Tsunami Loads and Effects Subcommittee chaired by Gary Chark and Ian Robertson in 2011, and have since been involved in development of tsunami provisions for the ASCE design standards. Our key contribution, NOAA's key contribution to the tsunami provision is the development of the original probabilistic tsunami design zone maps and the geodatabase for the coastlines of the Pacific states of US. These tsunami design maps are the basis of the ASCE compliant building design in the tsunami inundation zones. We also contributed to the continuous upgrades of these maps, particularly for Hawaii, for the integration into the 722 and 728 standards. Next slide. So Jennifer actually asked me to talk about some of the challenges we have encountered to prevent the last mile of the service from occurring for tsunamis. So instead of detailing the ASCE NOAA process of map development, I want to discuss some of the challenges that we faced and how the ASCE NOAA coordination efforts helped finding solutions to deal with these challenges. First of all, the Tsunami Committee comprises engineers, seismologists, tsunami modelers, academic partners, and government representatives. More than half the members were unfamiliar with the process and expectation at the initial stage of the ASCE code development. So the chairs of the subcommittee provide exceptional and dedicated leadership that was very instrumental in guiding the entire committee into a cohesive and productive team. The method of producing the code-compliant methods were developed from scratch, actually. Once the consensus was reached, there was not a lot of time left to conduct the model simulation for enormous map coverage, as shown by the maps on the right. Pretty much all parts of the coastlines of the 5 Pacific states, and before they are included in the balloting process. So the committee actually made a strategic decision to develop like maps with relatively lower resolution. The lower resolution we're talking about is like 60 meters for all coastlines for the 5 states, as opposed to a high resolution, we are talking about like 10-meter maps. This approach was like 60-meter maps was like kind of far more manageable within that time frame. But still could ensure the quality of the maps. So throughout the process, NOAA provided full support in high performance computing resources and additional labor. The committee also made a significant contribution with map illustrations. Next slide, please. So due to the urgency of the situation, actually another challenge arose from the need of the funding support for our modeling team at the NOAA Cooperative Institute at the University of Washington. So Jennifer and Gary worked very hard to secure some funding from internal ASCE, I think, COPRI, providing like very timely ASCE sponsorship that was crucial to ensure the maps were developed in time. The final challenge we faced was the sustainability of the code development. Specifically, the maps initially created at a relatively lower resolution needed to be upgraded to high resolution maps after the ASCE 716. So to address this issue, the NOAA ASCE coordination has become increasingly important over the past years. In California, the map updates were supported by California's Geologic Survey, which is a state effort. However, the high-resolution map development in Hawaii was sponsored by NOAA's Coastal Zone Management through the state government. The map updates in Washington and Oregon are being supported by each state government through the NOAA's National Tsunami Hazard Mitigation Program, NTHMP. What I want to emphasize here is that although a formal NOAA ASCE effort directly supporting tsunami hazards has not been established, NOAA supporting ASCE code development can be obtained through state programs and efforts. Next slide, please. So an exciting aspect of the ASCE NOAA coordination code development is that it has also created opportunities that benefit both ASCE and NOAA in terms of tsunami hazards. It has opened a channel of the conversation bridging ASCE, NOAA's NTHMP, and state governments in code development and implementation. On the other hand, we, like the NOAA FEMA, actually has been able to extend our collaboration with all kinds of partners that we haven't really reached out before, like the Department of State, other NOAA line offices, navies, etc. This is an example, like our ASCE compliant tsunami hazard assessment study assisted in the award-winning ASCE compliant design of the Oregon State University Marine Science Building in Newport, Oregon. That also serves as a vertical evacuation structure for the local community. By saying I'm going to stop here because of the time constraint. I can probably provide more thoughts during the Q&A sessions. Thank you.
Thank you so much, Yong Wei. Thank you so much. So we're going to we have 20-ish minutes left, 18 minutes left. I'm going to ask the panel, Terri, come on up. I'm going to ask the panel one question before we turn loose to the audience. So I want maybe one sentence from each of you. We're not going to do improvements. We're going to do what is the best aspect, what is working the best, what is working well from your perspective in your interaction with ASCE to develop our process for communicating or our process for developing the provisions. What would you say is the best takeaway that you want the audience to hear and learn from your experience from your agency? One sentence, not too long, because I want to have time for the audience, both in the room and online, to ask you questions. So I'm going to start with, we're going to go in the same order. We'll do Sanaz, Terri, John, Yong. One sentence.
Yeah, so the first one, what is working, I think with our USGS relation with ASCE 7, what really is working is the continuous relation that we have. It really helps us to improve things in the next cycle, and it also helps us to get funding and justify our work to the Congress. The second one, even though we have been working on this a lot, as I showed to you guys, we have it schedule coordinated years in advance. I still think what can be improved is the timeline and that coordination. So I feel like we're one of the agencies who have been working on this for the longest, but even from one cycle to the next cycle, we get so much complaints that, for example, from BSSC side, they need more time to review our model, and we get squeezed when we try to publish our model, because since our funding comes from the Congress, we have to have certain deadlines to publish our models. So our cycles, if you look at that table, have changed from 3 years to 4 years to 5 years and back again to 4 years. So that's still a difficult thing. So I want to urge people to just plan ahead. Even if you think you know what your schedule is, plan a little more.
Okay. I think what's working well is there's a good understanding between NIST and ASCE about what each party brings to the table, and good collaboration in terms of NIST understanding what ASCE needs to adopt something into a code and standard, and ASCE understanding that NIST has the capacity to do the research that's needed to support the changes that are needed in the next standard.
All right, John, you're up. One sentence. I know that's hard for you. John, you're on mute.
Okay, what's working well at FEMA is kind of what I alluded to, that the agency supports our building science disaster support program through the mitigation assessment teams. And when we perform those studies, we have the benefit of collaborating with several engineers who are also members and participants in the ASCE standards process, like Bill Colburn and Chris Jones historically. And so that it really works well, that our efforts to study, document, come up with findings, conclusions, and recommendations to enhance the codes is being done by a broad collaborative community, and that helps when it's presented into the ASCE standards. We also have the A&E support that helps us to do that. And what's really good about the ASCE process is, one, recognizing that it's a bunch of volunteers, but in that setting, the process allows those with a particular interest and expertise to contribute significantly different parts of the efforts in developing proposals, organizing the information, presenting it to the committee members for their use, for their discussion and votes. And so the last part is what's working well is, as we finish this process, that we will partner and collaborate with ASCE to get it, Jennifer, as you said, into the ICOES. And that requires special skill and expertise. So FEMA's longstanding role in that, especially in the International Residential Code, where the ASCE standards has to be translated more prescriptively. And so the process where we're collaborating and a lot FEMA's efforts are being fully utilized and leveraged, I think is working well. And our goal is that it will work well in the 2027 CICOES. Thank you.
Thank you, John. Okay, Yong Wei, tell me what's working well from the partnership, and then we have a question online all teed up for you guys.
All right. I think what worked well is like the exploration of the NOAA supports through the state initiatives that has resulted in kind of successful funding acquisition for ASCE code development. But I do want to mention an area that needs improvement is the echo. Can you still hear me? Hello? Can you hear me?
Sorry, we were getting a little feedback in the room. Sorry to interrupt you, Yong Wei. Yeah.
Oh, okay. This is the echo. Can you still hear me?
Yes. Yes.
But anyway, I want to mention that an area that needs improvement is the lack of structured long-term NOAA ASCE kind of agreement or platform of collaboration to address tsunami hazards. I would like to urge the task force team to include tsunami hazards in the team's like future scope of work. That's what I want to say. Thank you.
Great, thank you. The first question is from Mark. Process one because a lot of categories aren't.
Bilal has a question.
Yeah, go ahead.
Okay.
Go ahead, Bilal, as soon as you get a microphone.
Okay, well, are you going to answer this one or no?
Yong Wei, the question was, how are the tsunami maps treated for the territories?
The territories, they are in the process. For example, like Guam, actually, we have some map developed, but it has not been in the process of being integrated into the code yet. And for Puerto Rico, Caribbean area, that work has not been done yet. So we need to work on that. And that needs support from either NOAA, ASCE, or the state as well.
First of all, thank you so much for the excellent presentations, very informative. My question is about collaboration across the agencies, right? I think climate, as all of us recognize, cuts across all of the hazards, right? Everybody has to think about, well, how does it affect wind? How does it affect tsunami and so on? We just heard from Yong about making sure that the task force considers tsunami and so on. And I'm happy to know that NIST is working on a roadmap related to the wind tornadoes and so on. So I think the more we could bring all of these pursuits under the ASCE NOAA task force, and we are trying to do that, right, with the report and so on, I could see great value because we'd like to take that to the highest level, make sure that we'll feed it through government relations to get the funding that could impact everybody. I think if we pull forces together, we have a shot at it. And I could see it building up in that direction. So what I'd like to hear is the same thing for FEMA. I think, FEMA, at the very end, they are users of climate information and so on. So we need to figure out a working relationship that will meet the internal needs for each agency because they work within their own constraints, management projects, and so on, right? And the three of us as co-chairs, if I may speak on for the task force in here, we are flexible, adjustable, restructuring, whatever it takes to make sure that all of these needs are met and we'll come across in a strong way. Thank you.
So Bilal, what I'm thinking about in response to your question, going back to the presentation yesterday, is what one avenue of funding that would be what they call a supplemental. It's one-time funding. So, you know, we say this is something we're doing right now. How much do you need? Congress, you know, comes to however they determine the amount, and you get an amount with a statement about what they expect to be accomplished under that. You have to be careful because you can't fund multiple agencies under the same supplemental, nor to do the same task. It is not allowed. So we would have to say what NOAA is going to do, what FEMA is going to do, what USGS is going to do, what NIST is going to do. And I don't know that you can package those all together. The one thing I do know is NEHRP, right, is a model because they've had consistent funding. It's 4 agencies. Agencies get different amounts, but the consistency of the funding has allowed all the progress that you're seeing. There has been no such funding for wind events. FEMA, and John can speak to this better than I, has received funding for flood insurance mapping, right? But FEMA doesn't do basic research. So, you know, this is some of the understanding what each agency is allowed to do. NOAA's allowed to do research as well as meet, you know, community needs or national needs through their programs. So it's understanding what each agency is able to do, types of funds that they are able to receive, but also trying to find ways to get continuous funding, because it's this incremental funding. It's great when it's there, but when it's gone, it's, you know, you have staff and you can't really build a capability that way.
Thank you, Terry. We actually have Brennan online who has a question, and then I'll come back to you. Is that okay, Bella? A follow-up?
Great feedback. You see, the thing is, I'm trying maybe to see if we could coordinate in producing documents and reports so that there aren't competing messages. For example, we'll have, from this workshop, we are going to have a report. Ideally, would like to see if we could roll a lot of the needs coming in that report. It could be that you have a plan on a report for incorporating a climate into building codes and standards and so on. And this could be maybe referenced, cited as ongoing to show the details of how it will be done for wind. I could see something similar for tsunami. So I think if we do it, this coordination, what I'm looking for, and each agency could maybe articulate what are the needs there and the requests, maybe, or future pursuits for requests, right? It could be handled the agency needs. Yeah, coordination.
This is awesome because that's what we're going to be doing in the breakout. We're going to be noodling on what needs to happen and how it needs to happen so we can do that. I want to get to Brennan, and I want to get to anyone else who has a question for the panel online. So Brennan, go ahead.
Yeah, thanks. My question for the panel is, what role do these partner agencies have, if any, in helping ASCE facilitate adoption at the local jurisdiction level? And as a quick background, with snow, it's become my unfortunate part-time job to fight with every SCA west of the Mississippi. And I wonder if there's a better process for these, with these longer-term ASCE partnerships for encouraging adoption that we could learn from.
Anybody want to take that? An SEA is a Structural Engineering Association. So it's a local chapter of a structural engineering group. They're organized by state. Mhm. Yeah, oftentimes, but Brennan's particular unique case is that each state, because for a while, ASCE 7 didn't keep up with the data development, had developed their own state requirements. So now that we've caught up with like on a national scale, that's what he's talking about. So I think the question would be to what is the agency interest or ability to help locally?
I was just going to say both Yong and John have their hands up online, so they may want to get in on the answer to that.
Thank you for that. We can't see behind. Okay, Young or John, do you want to respond to that? And then I got Terry in the room.
Yeah, I just want to say, for example, like tsunami hazards, all the efforts, to the state level was done through NOAA supported this partnership between NOAA and the states, the National Tsunami Hazard Program. But one challenge we face is we're facing is that the NTHMP, the program, is taking a significant cut of funding due to NOAA's budget situation this year. So actually, a lot of efforts to the state was done through that program, and I'm not sure about the funding situation will affect and impact the state efforts in continuous effort in upgrading all the maps.
You call John.
This is John, and I think to respond, I think Brennan's question was how do we get to see more state and local adoption and implementation of these consensus standards? And for flood, we have to take a new approach. We are taking a new approach because less than half of the NFIP communities have building codes as we know it, through codes that are based off the model international codes, right? So the other half of these communities, and many are small, but they also have development. They also have construction and design, and we have to, in this effort, bring the benefit and the advancement and the resilience of these new standards to those communities, and do it in a way that the information from the standards is translated into the practitioners in that community. Now, one of the ways that we're doing that is by reaching out to that community, and that's why I'm here this week at ASFPM and not with you, because the first plenary of the ASFPM conference this week was about tomorrow's flood codes and standards. And the CEO of ASFPM, Mr. Chad McGinnis, thought that the advancements that are happening in the ASCE flood standards are so important, so transformational, that even as the CEO, he had to become involved as a voting member of ASC 24. Now, that's not going to get us to the finish line, but it's a recognition that we need to explore new partnerships and new avenues of collaboration with groups that we haven't before. And in flood, especially with the largest disaster, largest number of losses annually, staggering. This is the opportunity right in front of us, and we've started to make that collaboration happen. Thanks.
So just one other point, thinking about Brennan's question from a federal agency point of view, our participation on codes and standards is as individuals. We do not represent our agency when we participate in codes and standards. And that's very important to keep in mind. So if we went to the IBC code hearings, we would be there as an individual engineer, expert, climate scientist, supporting that measure based on a science perspective, because you don't want your federal agencies pushing consensus codes and standards. It's supposed to be a consensus among many stakeholders. So we're there as a stakeholder. It's not something that it's inappropriate for federal agencies to do that. What John is talking about is very helpful. Having information available, explaining things, directing things to awareness and to particular constituencies. And that's very appropriate because we're trying to improve, the national safety, well-being, and economy. But we cannot tell states what to do. We can't tell communities what to do. So you have to keep that roles and authorities separated.
Thank you, Terri. Okay, I have a question in the room from Chris, and then we're going to Jessica online. And then I think we're going to have to wrap up after that. I have some concluding remarks. So Chris, then Jessica.
I have a question for USGS and NIST. And when you have funding that's either episodic in the case of your tornado wind maps, or more sustained, as in the case of NEHRB, usually there has to have been a need clearly articulated, right? And people who feel like there's urgency to address that need. And then especially in NEHRB, consistent support to keep the appropriations there. So people have to believe there's a need. Can anybody remember in those two programs in particular, NEHRB and NIST wind maps, how the need was first articulated, messaged? Is that something we can learn from in order for us to be able to convey our need?
Well, I'll speak to the work we did with the wind maps. Part of the need comes from the lack of steady funding for wind research. Other than NSF, I don't know of any source of funding for wind. Our NWRP program is authorized, but it is not appropriated. It does not get funding. So we have to take it from our internal funding to support, that activity. That being said, when the Joplin tornado happened and we had an investigation, our investigations closed with recommendations. And Congress expects us to act on those recommendations and make improvements. That's part of the authority we have with that investigation. We don't have to do every single one, but we will often look to other agencies and ask them, if this isn't appropriate for NIST, is this something you would be willing to look at? So that is where the work for the tornadoes came from. And NEHRB, there are reports to Congress every year. And so Congress keeps track of what's happening in that program. And we get, discussions occasionally with Congress about questions they have, things they want to know, are we working on this or that? So that, in addition to the professional workshops, can help inform what happens. And Sanaz may have other things to add.
Sanaz, is there anything you wanted to follow up with the NEHRB justification or need?
Yeah, so this is actually an important part of the process at every cycle for our national seismic hazard model. We are funded, but we do have to justify the need for these maps every cycle. So like the last cycle was 2018, right after that, we had to justify that we wanted to go to the 50th state update because the previous one was 40th state. And in our justifications, we really rely on building codes now using our data and the necessity of that data in design. So the first few cycles, I can see it's a little more difficult to justify this, but this is actually a very important point for us going into every other cycle. We kind of go back and say, hey, look, IBC is a regulatory document and our maps are being used here. We can't just drop them and they do have to be updated. So it kind of like helps us there to justify this and vice versa. It's like a chicken and egg thing at this point after having gone through it a couple of cycles.
Thanks so much. We have a question online from Jessica.
This is for John. How is the support from FEMA and their
Okay. Can you hear me? It froze for me.
Okay.
We can hear you, John.
I see the question. I'm ready to respond. That's a great question, Jessica. Thank you for that. I think that can be explained. You know, what happened before and what's happening now is the cycles between 24 and 7, right? And how they were not in sync or close, and now those cycles are convening. So if you think back, you know, we put a lot of effort into the ASCE 24, the 14 edition, right? And our attention shifted to getting that implemented, right, into the I-codes, and then getting that implemented into the agency's grant programs as a reference standard that must be complied with, and then supporting that with training, outreach, dissemination. So you know, with the 22 ASCE 722 cycle beginning in 2016, I don't think it was intentional that we were not there. It's just that we were very much focused on implementation, integrating into policy, development of agency building codes policy, minimum standards policies, and then the emergence of our building code strategy. So it's sort of like where was FEMA? That's what we were doing on the implementation end. And then luckily we came in towards the end of the process to support that. Going forward, and my colleague John Westcott is here too, we are strengthened by the agency's building code strategy. We have clear goals and priorities. That effort is broad, but it also includes strengthening the capability and capacity of our nation and utilizing codes and standards. So you know, the building science group is a small but mighty group. Remember, it's not the NFIP, it's not the grant program, it's not the mapping program. So we have to make the case to be funded and supported, and to the best that our abilities, we're going to continue to do that. And the recognition now is that these standards are on a parallel path and a complementary alignment, if you will, with FEMA's future flood risk data. So that's more reason to hopefully expect and benefit from investment and participation in both in completing what we're doing this year and then participating in the next cycle. Yeah.
Thank you, John. Thank you, Sanaz. Thank you, Yong and Terry. I'm just going to wrap us up here, and then I'm going to invite you all to stay on. If you have the time and the ability to do so, we welcome you to stay on. We're going to lead into our next session, which I took 10, 15 minutes of your time, Dan. So thank you for that. But I just wanted to wrap up and say in summary what I heard, and this is the food for thought as we move into our breakouts in a little bit. What I heard from the agencies pretty clearly was continuity of staff. These are improvements. These are what's working well. Continuity of staff to work with the engineering community, understanding the need directly from technical need as well as the communications need, the end goal, where does the data live? Agency support at the highest level. To continue that program within the agency is fairly important. And then partnerships for adoption. I also heard federal and state collaborations, as in the case of the tsunami data development that started off at the federal level, and then we partnered with each state that is affected by those provisions, and they put in more money to the pot to develop their data for their coastlines. So that's the way that worked. So I would say the key, what I heard from everybody on this panel, the key is getting agency-supported work into the documents, into the standards, into the codes, into the requirements. That feeds the do loop, the feedback loop, if you will. So you work hard, we get it adopted, we work hard again, we get it adopted, and we can demonstrate the impact. And again, I would say, the more we do that, the more we get it adopted into the regulatory environment for whatever that is. For me, it's the building code. For Brian, it's something different. For Jen, it might be something different for COPRI and EWRI standards. But getting that into the regulatory environment, what does that do? Ding, ding, ding. Improves our infrastructure resilience, improves our community resilience. So that's the prize we're keeping our eye on.